Alright, welcome. Today we're going to be continuing with circles. We're going to go a little bit more in depth into arcs and chords. So if you remember from last time, an arc is a curve that goes around the exterior of the circle, and a chord is a line that connects two points on the circle. Excuse me. So the first theorem that we want to look at today is the fact that if I am given congruent arcs, that means the chords that connect the endpoints of the arc are also congruent. So if I look at the picture to the right, if FG is congruent to JH, then the segment from F to G is also congruent to the segment from J to H. So our example is pretty straightforward. They tell us that AB and CD are congruent. So if the two chords are congruent, then the arcs must be congruent as well. So if AB measures 60 degrees, then CD measures 60 degrees as well. That's all there really is to that. All right, in our next example, we're going to follow along with the same theorem. We notice that they have marked the arcs as congruent, which means that our segments are congruent as well. So if MN is congruent to PQ, then that means 2x plus 1 must be equal to 3x minus 7. And now we can solve for x. Question told us to find PQ. So we just plug into our formula. And we get P to Q equals 17. Alright, so the next thing to look at is that if we are given a chord that makes a right angle with either the diameter or the radius, then the chord is bisected. And of course, if the chord is bisected, that means the arc is bisected as well. So when we're looking at our examples, we know that both halves of the arc are the same and both halves of the chord are the same. So we notice that QS is the radius. We've got our right angle here. If they tell me that PQR is 98, PQR would be there. That means that the two pieces of the arc are the same. So divide the 98 in half. And there we go. So the measure of PQ is 49. All right, example 4 is going to use the same theorem, only it's going to be a little more complicated when it comes to the math. So if we look at what we are given, we know that the diameter of the circle is 30 inches, and the chord from K to M is 22 inches. We're looking for JL. So if we find point J, we find point L, this is what we're looking for. We notice that J to H is a radius, so we've got a radius here. Or another way to look at it is that we have a diameter from G to H, We said anytime the radius or diameter makes a right angle with the chord is split in half. So if there's 22 inches from K to M, we bisect it and know that there are 11 inches on either side of point L. Also, if the diameter of the circle is 30, we know that the radius is half of that, so there's got to be 15 inches from G to J. So we know that JL is less than 15, but we don't actually know how JL and JH sort of split up to form the radius. But we do know that the radius of the circle can be drawn to any point on the circle, right? It can go any direction. So all of the line segments that I just drew were 15. Well, if I look at what I'm solving for, I know that I can connect J and M to get a radius, and that will create a right triangle. So if I copy my triangle over here, we said there's 11 inches going across the bottom. We said that there's 15 inches from J to M. And JL is what we're looking for. So now we have our Pythagorean theorem. So x squared plus 11 squared equals 15 squared. X squared is going to equal to 104. So we take the square root and we should get that x is about 10.2. X was equal to JL, and they told us that each segment was measured in inches. So there we go. So again, the trick is to remember that the radius can go to any point on the circle. So usually when we're looking for missing lengths, we draw the extra radius or diameter, and then that will set up a right triangle. Alright, so our last theorem. If the chords are the same length, then the two chords must be the same distance from the center of the circle. So when we see the right angles on two congruent chords, we know that the segments coming from the center must be the same size. So in our example, they tell us that WX and XY are both 22. So if WX is congruent to XY, that means that AB must also be congruent to AC. So if AB equals AC, we can use the equations that they gave us to solve for X. And then again, we go back to the question. It wanted us to find the length from A to B. So AB is 5x, x is 2. So AB is 10. And that's all we have for today. I'll see you guys next time.